Section 6.3. What we're going to do here is our next thing with fractions, our next thing with our rational expressions. What we are going to do is we are going to simplify these things called complex. And anytime you see the word complex, you start to freak out, like math's not complex enough, and now mathematicians tell you it's complex. We're going to talk about complex fractions. Now, don't worry about the word complex. Okay, I think actually this section here is among the if I were doing a spectrum, I think it's among the easier of the sections in this unit. Okay, so complex, all complex fractions means is you have little fractions inside of a big fraction. Okay, so for instance, here's an example of a complex fraction. I've got x plus 1 over x. That's my numerator. I'm going to put a bigger fraction bar here to distinguish. And then I've got x minus 1 over 2x at the bottom. That's a complex fraction. And they're gross, and we don't want them to be complex anymore. We want to make this into a normal fraction, because those are bad enough. Now, there's two situations I'm going to show you. This is the simpler situation that we can do something on this problem that we already know how to do. So what I want to show you here is if you have a situation where you have one fraction in the top, and you have one fraction in the bottom. So please make sure that you can identify why I am saying that there is just one fraction in the top and the bottom. When you have one fraction in the top and one fraction in the bottom, it's just a division problem. And we talked about dividing last time. Does anyone remember the process? It was 3 words. What's the process for dividing fractions? Keep, change, flip. Okay, that's the process. Okay, or I think in this class somebody else said leave, change, flip. Doesn't matter. Either one. We're going to keep, change, flip. So we're going to keep the top fraction, the x plus 1 over x. Remember, fractions just mean division. So I'm going to change this middle fraction bar, this division. I'm going to change that into a multiplication problem. So I'm going to put a dot here. And then I flip the bottom fraction. So instead of x minus 1 over 2x, I flip it around to 2x over x minus 1. So when I have one fraction in the top, one fraction in the bottom, my complex fraction is just a division problem. That's it. And so here, I'm almost done. I can cancel. There's one thing I can cancel out of the top and the bottom of this problem. What's that one thing? There's an x. So I can get rid of the x here. Whoop. I can get rid of the x here. Whoop, gone. So now my answer is 2 times x plus 1 in the top. So I'm just going to 2 times x plus 1. Then I've got an x minus 1 in the bottom, and we're done with that complex fraction. So I'm going to have you do 2 like this, just to make sure 2 things. When you're doing these next 2 problems, just make sure you can say, okay, do I see that that's one fraction in the top, one fraction in the bottom? Or I should actually just say one term in the top, one term in the bottom, but we'll differentiate that in a minute. So try this problem. You've got y plus 2 over 5y. That's the numerator. In the bottom, you've got y minus 2 over 3y. Super similar problem, just what I did. So give it a try. Okay, so it's a multiply problem, so I'm just going to change it. At the top, I keep y plus 2 over 5y. We keep that. We change this division bar in the middle to a multiplication. Then I flip the bottom fraction. It's called the reciprocal to 3y over y minus 2. Again, there's one little thing that'll cancel here. I can cancel this y here with that y. There's no other common factors. So my top is 3 times y plus 2. And my bottom is 5 times y minus 2. And there we go, we're done. One more like this, and then I'm going to show you the other complex fraction situation. I think once you've done one or two of the other situation, I don't think it's any worse than what we're doing right now, but it's just a matter of going through the process a couple times. So here is one more of one fraction term in the top and one fraction term in the bottom. So I got t plus 4 over 3t squared divided by 2t plus 1 over 9t. All right, so one more time, I'm going to keep change flip. So I keep the top, the t plus 4 over 3t squared. I change my division to multiplication. I flip the second one to 9t over 2t plus 1. I've got a couple things that'll cancel. The first thing is I've got a t here. It'll cancel with one of those t's. And then I've got 3. 3 goes into 3 once. 3 goes into 9 3 times. That's it. There's nothing else. So if you went any further, you've canceled things you can't. So in the top, I have 3 times t plus 4. In the bottom, I've got t times 2t plus 1. I'm going to leave those factored. There's no reason at all to multiply them. If you want to, it's great. It's right, but it's just extra work. That's the first situation. The second situation of complex fractions looks like this. In the top, I've got 2 plus 1 over y. In the bottom, I've got 3 minus 2 over y. Now, I know this problem still has one fraction in the top and the bottom. I should have written over there one fraction term. Notice, even though I just have one fraction, I have 2 terms. I've got a 2 here plus a 1 over y, a 3 minus 2 over y. So what I have is in the top or the bottom, I have more than one term. So unfortunately, I can't keep change flip on this problem. It's not in the right format. Now there's 2 ways we could approach this. And again, I think I'm giving you the simpler way to do this. If you've seen this by chance before, you might have had a teacher that said what we're going to do is we're going to add these fractions and combine and make one term in the top and combine and make one term so that we can keep change flip. But I think that's too much work. Okay, so we're not going to do that. What we're going to do is we are going to do what's called we're going to clear the fractions. The reason I like this is because when we come back next class, we're going to talk about solving equations with fractions, and we're going to use this exact same process. So we're going to get 2 for 1. And what clear the fractions means is I'm going to multiply every term by the least common denominator, the LCD, which we were practicing finding in the previous section. Okay, so I've got two fractions here. I've got 1 over y, I've got 2 over y. What's the common denominator between those two things? Y. Exactly, just y. It's the only denominator. Okay, so the LCD of this is just y. I'm going to write that down over here. You might say, why not the 2 and the 3? The 2 and the 3 aren't fractions, they're whole numbers. So I don't need to worry, they don't have a denominator. So now what I'm going to do is to each of the 4 terms that I have, I'm going to multiply each of them by y. So what I'm going to do is I'm just going to take my red pen here and I'm going to multiply each by y. So I'm going to multiply this term by y. I'm going to multiply here by y. And since it's a fraction, I'm going to write y over 1. I'm going to multiply the 3 by y. And I'm going to multiply this fraction by y. I'm going to write it as y over 1. Every term I multiply by y, which is the common denominator. And we're about done with this problem, unless it simplifies. I don't think it does, but in case. So here's what we do. We're going to multiply everything by y. So on the top, 2 times y, well, that's 2y. Great. Plus, the next thing, oh, these y's cancel. That's the whole point of clearing the fraction. You should multiply by something that makes these fractions go away. And what I'm left with is 1. In the denominator, y times 3 is 3y, minus, and then again, 2 over y times y over 1, the y's cancel. Again, that is the whole point of clearing the fractions, is to make the fractions go away. And then I'm left with 2. And we're done. I've taken my complex fraction and I've made it a normal fraction. It looks reasonable now. So, way we're going to end our time, we got about 20 minutes left. That's plenty of time. I've got 3 or 4 or 5 or 19 of these problems for you to do. It just depends on how it goes. So here's a problem that's almost exactly what we just did. 4 minus 3 over x in the top, and then 5 plus 2 over x in the bottom. So please simplify that complex fraction. Get rid of the little fractions that are in the big fraction. What's the least common denominator? Just to give us a nudge. Just x. Yes. Said with confidence. I love it. Good job. I'm going to multiply every term here by x. So the first term by x, the fraction by x, which I'm going to write as x over 1, the 5 by x, and the last fraction by x, which I'm going to write as x over 1. The end result should be, I should get rid of those little fractions every time. So in this one, I've got x times 4, that's 4x. Here, the x's cancel, and I'm left with 3. 5 times x is 5x, plus here the x's cancel, and I'm left with 2. There it is. You should have 4x minus 3 at the top, 5x plus 2 in the bottom, nothing factors. I can't simplify that in any way imaginable. Here's another one. Okay, so again, take a moment, identify the common denominator, and then we'll do that together. So you have 5 minus 2 over y, and then 4 plus 1 over x. So first thing is, what is the common denominator? What's the common denominator of these fractions here in this problem? You need an x and a y. You got an x here and you got a y there. So you need one of each. One of everything you see and then highest power. So x times y. So what you're going to do now is you're going to take that common denominator of x and y and you're going to multiply by each of the 4 things. Okay, we always multiply by the same thing. So multiply all 4 things by x times y. All right, so I'm multiplying each by x times y. So in the top, the 5 times the x and y, that's just 5xy. That's great. Minus. Now help me out here. I've got 2 over y times x times y. What cancels? The y's do. And so what's left now for that term? 2 times x. Great job. Love it. In the denominator, I've got x times y times 4. That's 4xy plus, and then x times y over x. The x's cancel, and that just leaves 1y or y. I could factor an x out of the top and a y out of the bottom, but nothing's going to cancel, so it's not really worth my effort. If you want to, it's right, and you can write it all factored, and it's beautiful, but it's not any simpler, so we're going to leave it. Here's another one. I've got 2 more I think we have time for. If we have time for a third, we'll do it, but we definitely got time for these 2 right here. So here is your next problem. We've got 1 over x plus 1 over y in the top, and then 1 over x minus 1 over y in the bottom. So take a minute, write that problem down, and then please identify the common denominator, and then I'll get with you, and then you'll finish the problem. What's the common denominator here that we're going to work with? Perfect, x and y, great. Multiply all four things now by x and y to get rid of these little fractions. So here goes. When I multiply the first fraction by x times y, the x's cancel, and I have 1 times y, or just y, plus the next fraction, the y's cancel, and I have 1 times x, or just x. In the bottom, the x's cancel again. I have 1 times y, or y, minus, then next the y's cancel, and I have 1 times x, or x. There's my new fraction. That means the same thing as the original one, but we don't have all the little fractions, so we're not as bothered by it. All right, here's another problem. I like this one, lots of m's and n's. So m over n minus n over m. In the bottom, 1 over m plus 1 over n. The reason I'm given this problem is because I don't want us to forget that after we have simplified things, our end result is to make sure the fraction's reduced. Okay, so that hasn't occurred too much for us. But I want to make sure that's still on your mind. So identify the common denominator, then we'll work the problem. What's the common denominator of these fractions right here? 1 each, m and n. So I'm going to start writing it down, but if you're working it, keep working it. We're going to multiply each of these by m and n. All right, so here goes my first term. The n's cancel, and now I have m times m, so m squared, minus the next fraction, the m's cancel, so I have n times n, or n squared. Here in the bottom, the m and m's cancel, so I have n times 1, or n, plus, and then here the n's cancel, and I have 1 times m, or m. So if you got there, you did great. That's the complex fraction part of it. The last bit is just remembering to simplify. The top is a difference of squares, so I can factor that. M squared is M times M. N squared is N times N. Since it's a difference of squares, we have plus one minus the other. Oh, I do have something in common. M plus N is the same thing as N plus M. It doesn't matter what order you add things in, so I can cancel that. And I'm left with M minus N over 1, or just M minus N. And as happenstance would have it, we do have time for one last problem, which I'm glad. This is a great problem. You're going to be so happy you did it. So we've got 1 over x plus 1 over y. 1 over x squared minus 1 over y squared. So again, I'm going to give you a moment. Please determine what the common denominator is, and then we will get to the business of doing this problem. All right, common denominator. Throw out what you think should be part of the common denominator. X squared. We see the factor x, we see the factor x here, and we see the factor x here. And I told you when you need one of every factor, so we clearly need an x, and we always take the highest power. So x squared, yes. Then, just as I was told, I see a factor y, I see a factor y. So I need a y in the common denominator. And we always take the highest power. So again, that's squared. So there's your common denominator. You're multiplying each of the 4 terms by x squared and y squared. All right, I'm going to get started just for time's sake. So if you've got questions, let me know. So here we go. I've got to first get rid of the fractions. So the bigger test here, I think, is going to be simplifying. So here I've got an x and I've got 2 x's. So this x will go with one of those. And so I have x times y squared times 1. 1 times anything is just that thing. Here, this y cancels with one of those. So I have x squared y times 1, which is just x squared y. In the denominator, these 2 x's will cancel with both of those. That'll leave me y squared minus And then here the y squareds will cancel, and that leaves x squared times 1, or x squared. Bottom's a difference of squares. The top has a common factor. Each of the terms has an x. Each of the terms has a y. So I'm going to factor out an x and a y. And when I factor out the x, I have one x. I factored one out, so no more x's. I have two y's. I factored one out, so I have a y. Plus, I got two x's. I factored one out, so I have an x. I started with one y. I factored it out. No more y's. My difference of squares, y squared is y times y. We just saw this a moment ago, except with m's and n's, there's no difference. And look at that, I've got a common factor. It's all worth it when you got a common factor. That's great. And so I have x times y on the top, y minus x in the bottom. So that's working with fractions, working with common denominators. Like I said, when we come back next time, we'll probably do one more of these problems just to kick up where we left off. We're going to use the common denominator again. So please practice finding it. Make sure you're comfortable with it. We are through section 6.3. You can do all the homework in section 6.1, 6.2, 6.3.